Good afternoon, class. We are looking at exam 4 review covering chapters 4 and 5. And here's the third part, 5.2, the definite integral, and 5.3, the fundamental theorem of calculus, short FTC. The definite integral. Suppose a continuous function f is defined on the interval of a to b, a closed interval. The interval is divided into n subintervals. Delta x, the width, will be b minus a over n. X sub 0 is a, x sub 1 is a plus delta x. And it continues all the way to x sub n, which is a plus n delta x, or b. Then a Riemann sum associated with f is the following sum. The integral of a to b f of x dx is equal to the limit as n approaches infinity of summation of I going from 1 to n f of x sub I delta x. So this means f of x sub 1 times delta x all the way to f of x sub n times delta x. And again, delta x is b minus a over n. X sub I is a plus I delta x. In this case, actually it would be the right endpoints where x sub I is any point chosen in the subinterval of a sub I minus 1 and a sub I. That's the definition. Let y equals f of x be continuous and non-negative over the interval of a to b. A definite integral is the limit as n approaches infinity equivalently delta x approaches 0. Whether delta x approaches 0, which is b minus a over n, or n approaches infinity means the same thing, of the Riemann sum of the areas of rectangles under the graph of y equals f of x over the interval of a to b. So the area under a curve, I'm assuming it's a non-negative, it's a positive function above the x-axis. The area is the limit as n approaches infinity of the summation of I going from 1 to n. F of x sub I delta x is b minus a over n, x sub I is a plus I delta x. This is the definition of a definite integral. We will look at this process and then we will look at fundamental theorem of calculus that makes it easier to calculate. So the definite integral. Let's see what we have here. Integration symbol. The symbol was introduced by Leibniz and it's called integral sign. It is an elongated S. Take a look, elongated S, and was chosen because an integral is a limit of sums. Here's the lower limit of integration. This is the upper limit of integration. This is the integrand. This is a variable of integration, also known as dummy variable. It is called a dummy variable because the answer does not depend on the variable chosen. The dx simply indicates that the independent variable is x. Now, the integral of a to b f of x dx is a number. That's why it's called a definite integral. It's just a number. It does not depend on x. We could use any letter in place of x without changing the value of the integral. The integral of a to b f of t dt gives you exactly the same answer. Or the integral of a to b f of m dm. Okay. Its approximation, the integral of a to b f of x dx, is the Riemann sum summation of I going from 1 to an f of x sub I delta x, which is f of x sub 1 times delta x all the way to the last one. This sum is called the Riemann sum. If you want the exact answer, you have to take a limit of this expression and let n go to infinity. So the actual area, the precise value, is the limit of the summation of, limit as n approaches infinity of the summation of I going from 1 to n, f of x sub I delta x. And again, this methodology we will look at, but there is an easier way by fundamental theorem of calculus, which is actually written here. We will do to evaluate. So first, Let's look at a couple of basic questions, starting with this one that says, express as an integral on the interval of 0 to pi. So we want to first dissect this concept. So this limit versus this definite integral. We said the integral of a to b f of x dx is identical to the limit of the summation as I goes from 1 to n and approaching infinity of f of x by delta x. So if they give you this format, you should figure out this one. If they give you this format, you should figure out this one. That's what we're going to start with. So this format is given. We want to know this format, which means we need to find f of x. We need to find the interval and rewrite it. The interval is given. So a and b, believe it or not, is given when we say express it over the interval of 0 to pi. So a is 0, b is pi. So that part is known. So using the fact that the two are equal, this becomes f of x of I okay, and delta x happen to be given as delta x. So if this is x of I, what is f of x? The same thing without the I. So f of x is x cubed plus x sine x. So same thing without the I. A is 0 as it was given here, and b is pi as it was given here. So just plug in. So we're going to say the integral of a to b, 0 to pi. F of x is this function. Instead of delta x, we're going to use dx. So we are going to write the given limit is equal to the integral of 0 to pi x cubed plus x sine x dx. So it's very straightforward, everybody. Again, this is just to remind you about what we were just discussing in the previous pages. Express as an integral the limit as n approaches infinity of summation I going from 1 to n of sine of 2 pi I over n times 2 pi over n on the interval of 0 to pi. So right away, a and b are given. So I want you to notice that. So we want to write the integral just like similar to the previous page. So we need to figure out the a and b, which is given, and the function f of x. So let's compare. We know the integral of a to b f of x dx is this limit where the interval is a to b. So we have no problem with the interval. Let's look at f of x over here. We call it f of x of I. Delta x changes to dx and vice versa. So a is 0. B is 2 pi, everybody. Delta x, b minus a over n. So 2 pi minus 0 over n, 2 pi over n. And so this is the delta x. X of I equals a plus I delta x. A is 0. I delta x is 2 pi over n. So we get 0 plus I times 2 pi over n. or 2 pi I over n. So this is x sub I, everybody. This is x sub I. So in essence, you're looking at sine of x sub I. This is, so let me just erase, makes it easier to write then. So this is sine of x sub I. This one is delta x. So f of x sub I is sine of 2 pi I over n. So f of x becomes sine x, and the interval is given as 0 to 2 pi. Therefore, this limit is equal to the integral of sine x dx from 0 to 2 pi. So again, just recognition of the limit versus the integral format. We want to make sure that we get that. And it's very straightforward, everybody. All right, let's move on. Use summation formulas to compute the integral of 0 to 2, 1 minus x squared dx. And we know the integral of a to b f of x dx is the limit of this sum. Class, generally speaking, this is pretty long and difficult. I want you to know. Tedious, I shouldn't say difficult. Ultimately, we have an easier method, and we will get to that. But for now, just by definition, so this is defined to be this limit. So how do we get to this limit? So there's some stuff that you need to know. For example, summation of 1 is n. I going from 1 to n in all cases. Summation of c is n times c. Summation of n is n times n plus 1 over 2. Summation of I squared is n times n plus 1 times 2n plus 1 over 6. And summation of I cubed is n squared times n plus 1 quantity squared over 4. So we are going to find this and then take a limit. So first, we are going to find and simplify this portion. To do that, we are going to follow the information here. And that is, what is delta x? B minus a over n, 2 minus 0 over n. What is x sub I? A plus I delta x. So we're going to write those. So f of x is 1 minus x squared. The interval is 0 to 2. A is 0, B is 2. So this we can get from the integral. One more time. Here's the function. Here's the lower limit a. Here's the upper limit b. We are going to go with delta x being b minus a, 2 minus 0 over n. Then x sub I is a, which is 0, plus I times delta x, which is 2 over n. And when you do that, you get 2i over n. Now that we have x sub I, we can find f of x sub I delta x. If f of x is 1 minus x squared, then f of x sub I is 1 minus this expression squared. So So put it in there. So this expression, this limit becomes the following. 1 minus x squared, 1 minus 2i squared over n, times delta x, 2 over n. So that is the delta x, everybody. So that's pretty straightforward. Now, we are going to raise this to the power of 2 and multiply by 2 over n. First of all, this becomes 2 over n. This becomes 4i squared over n squared times 2 becomes 8i squared. This one times n becomes n cubed. So this is what we get. 2 over n times 1 is 2 over n times the second piece is minus 8i squared over n cubed. When you want to evaluate this limit, you have to know this. And to finish the job, you want to make sure that you either take everything out of the limit and you keep 1 in there, or if there's a constant, you can even take the constant. If you take the constant out, class, this becomes c, this becomes 1, and it becomes n. That's actually the justification for that, this part. So you can see this is c summation of 1, I going from 1 to. So you stick with 1. Then I squared, I cubed, we want to keep it. So for example, this one, we can just look at 2 over n. You can say the summation 2 over n times the summation of I going from 1 to n of 1. This one, take minus 8 over n cubed out. So this is elementary algebra. One more time. The first piece, you can take the 2 over n out, summation of 1. The second piece, you can take minus 8 over n cubed out, summation of I squared. All right. This one can be replaced with this. This one can be replaced with this one. So we do that. Clearly, this is 2. We don't have to worry about that. But what happens here? The denominator is 6n cubed. The numerator, everybody, I hope you can see that we have n times 2n. We have 2n cubed, and I'm not going to even write the rest. And of course, I have a lot more, but I don't worry about that. And I'll tell you why in a moment. I just want the leading term. N times n is n squared times 2n is 2n cubed. So this simplifies to 2. This simplifies to 8 times 2, 16n cubed, and the rest of them. And again, the rest of them doesn't matter what they are. Why is that? Because I'm going to put this into the limit. Now this, I'm going to take a limit. So this integral is the limit of what you see here. And what you see here, if you recall, when you have a rational function, if the degree of the numerator and the denominator is the same, it's just the leading coefficient. So this becomes 16 over 6. So the answer is 2 minus 16 over 6. Two is 12 over 6. The answer is minus 4 over 6, which simplifies to negative 2/3 as the final answer, everybody. So that's pretty straightforward. We are going to move on. I'm going to recap something quickly. To get to this, there is an easier way known as FTC we're going to look at later on. However, for now, we go with the limit. And when we go with the limit, it takes quite a few steps to do the job. The methodology is to find this expression and then replace the summation of 1, summation of I squared, I cubed with the right-hand side. And then when you take a limit, you get to the answer. Given f of x equals x cubed minus 6x, evaluate the Riemann sum, taking the sample points to be right endpoints. First of all, here's the graph, and we want to evaluate the Riemann sum, but let's just understand the concept here. A is 0, B is 3, C, N is 6. So we're going to go from 0 to 6. So we want the following area, everybody. That's the area we want. Now, how do we find this area? Well, it doesn't look like any geometric shape, so we don't have a formula for it. So how do you find it? You cut it into pieces. First, let me quickly show you something that is a little bit easier to follow. So for example, if you want this function from A to B, and you're interested in getting the area under the curve. By the way, when the function is positive, that represents the area. This Riemann sum and the integral. If a portion is positive above and a portion is negative below the x-axis, then it's the difference of areas, which means in this case you get a positive value because it represents the area. In this case, depending upon whether this area is larger or not, you can see probably this is larger, so you end up with a negative value. But so how do you find this area? We don't have a formula. So you cut it into pieces. For example, and I'm making this up. Let's say I want to cut this into 3 pieces. So delta x is b minus a over n, and now in this case is b minus a over 3. And so you draw these rectangular strips. Each one has the width delta x b minus a over n. Now, what is the height though? Well, you can pick any number in between, and the height would be the functional value at that point. So if you choose the left endpoints as the height, you get this one, and this one. So those 3 you can calculate. So what would that be? Would that be the area under the curve? No, that would be an approximation. So I use the left endpoints. Or I may use the right endpoints, which becomes this one, and this one. Again, is that the area? No, it's an approximation. Or you may use the midpoint or any other point in between. That is an easier function to understand. For this one, it's a tad more difficult. I thought, I mentioned that. So with that being the case, what do we need to do? The function is x cubed minus 6x, and a is 0, and b is 3, and n is 6. We can calculate delta x. So these are the given. I'm not writing anything new. These are given. Delta x is b minus a over n. So 3 minus 0 over 6, or 1/2 of 0.5, 1/2 of 0.5. Okay, doesn't matter. Now, the best course of action is to do the following. You want to go from A, which is 0, to B, which is 3. From 0 to B, which is 3. So let me actually write 3 here. You draw a line segment 0 to 3, and you cut it into whatever n is. In this case, n is 6. So you cut it into 6 pieces, and therefore you're dealing with each sub-interval or width of 0.5 or 1/2. So you cut this into 6 pieces as follows. Notice the endpoints that we are using are the right endpoints. So if you look at the first one, here, this is 0.5 or 1/2. This is 0.5. Okay, 1, 1.5, 2, 2.5. So I can take the left side, which has a height of 0, or the right side, which has this height. This one, the left side would be here, the right side would be here, so on and so forth. Now for this piece, the right side and the right side. And so what happens if you look at each rectangle has the same width, delta x, or 1/2 or 0.5. What is the height? For this one, the height is this one, this distance. For the second one is this distance, and so forth. So we are going to write delta x times. Now, if we are going to go with the left endpoints, we don't use b. If we are going to use the right endpoints, we don't use the first one, a. So we're going to start with 0.5. So f of 0.5, for this one is f of 1, for this one is f of 1.5, and then f of 2, f of 2.5, f of 3. So delta x, so this is your delta x, everybody, 1/2. F of 0.5, f of 1, f of 1.5, f of 2, f of 2.5, and f of 3. For example, and I'm gonna give you the final answer because that takes a little bit of time to calculate. For example, if I want 0.5, I plug in 0.5 into the function. And that gives me 0.5 cubed minus 6 times 0.5. I want 1, 1 cubed minus 6 times 1, and the rest of it. You put them together, you get negative 3.9375. Is this the area under the curve? No, it's the difference of areas. Is this right? It's an approximation. Note this value represents the difference of areas, not the area under the curve. If you want pure area, you have to go with the absolute value. And the reason it's the difference of areas, because a portion of the graph is above the x-axis, which is positive, a portion is below, which makes it negative. So that's an approximation, and we use the right endpoints. And by the way, we've already discussed the left endpoints, the right endpoints, and so forth. Everybody, I hope, is okay with that. We are just reminding everybody of what we've done. And of course, this is a tedious methodology, but that's how we get started. Part B says actually evaluate this. And again, we are going to go with the limit. So what is the function? X cubed minus 6x. What is A? 0. What is B? 3. And this is the area we want, by the way. Difference of areas. Delta x is b minus a over n, which makes it 3 minus 0 over n, 3 over n. X sub I is a plus I delta x. A is 0. Delta x is 3 over n times I, so 3i over n. And now we are going with the limit here. We need f of x sub I delta x. So this is equal to this limit. And we are going to find that. So what is f of x sub I? So this is f of x. F of x sub I would be 3i over n cubed minus 6 times 3i over n. So we want f of 3i over n times 3 over n. This is the delta x. F of 3i over n, as I mentioned, is 3i cubed over n minus 6 times 3i over n. So this is f of x sub I, everybody. So this piece is this. So let's work on this. This becomes 27i cubed over n cubed. This becomes minus 18 over n times I. The entire thing times 3 over n. Now, we can put 3 over n outside if we want, because the summation pertain to I, okay? All right, so we have again 27 over n cubed I cubed minus 18 over n I. And I put them in different colors because when you get to use that, you have to have either one here, I squared or I cubed. So I'm going to take this one out, and I'm going to take this one out. So we have, if I cut this into two pieces, 27 times 3 is 81. N cubed times n is n to the power of 4 times I cubed. If I multiply this to 3 times 18 is 54. So minus 54 over n squared, summation of I. This is extra. Now, this part will be replaced by this. This part will be replaced by this. So we have, everybody, 81 over n to the power of 4. Summation of n, summation of I cubed is n squared times n plus 1 quantity squared over 4. Minus 54 over n squared. And summation of I is n times n plus 1 over 2. So this is the limit of that. So we have to take the limit of this. To take the limit of this, I want you to notice the following. This becomes n squared. So this entire thing is n to the power of 4 and something else with powers of n going down. And this is, of course, this is just n squared plus n. We are interested in the leading term. So according to this is equal to the limit as n approaches infinity. For this one is 81 n to the power of 4 over 4 n to the power of 4. 81 n to the power of 4 over 4 n to the power of 4 minus, now this one is 54n squared over 2n squared. So please understand this. So that should be pretty straightforward, everybody. Now, this one, everybody, same degree. So it's 81 over 4. Same degree, 54 over 2. And becomes different color. Becomes 108 over 4 minus 27 over 4. So that's, I hope, pretty straightforward. Should be pretty simple. It's just a matter of evaluating the limit for a rational function, everybody. Now, as I mentioned, this is tedious, but that's by definition. Now, evaluating integrals using signed area. Use the signed area interpretation of the definite integral to compute the integral of -1 to 2x dx. So I want to discuss this. And this is a very simple function. the function f of x is x, and the interval is from -1 to 2. And all you have to do, graph this y equals x. Y equals x is a line that goes through the origin. And we want to go from -1 to +2. So this will help you actually understand the previous ones better. So what we want is this area actually minus this area. And here's the reason. Because this portion is above the x-axis is considered positive, below the x-axis negative, therefore we want the difference of areas. And those are easy to calculate because each one is a triangular shape with the area being 1/2 base times the height. And we are going to write this point as coordinates 2, 2. So this distance is 2, so is this distance. So that would be 1/2 2 times 2, which makes it 1/2 base times the height. For the red one, this point has coordinates -1, -1, which makes the distance 1, and 1/2 of 1 times 1 is 1/2. Their difference is 3/2. 2 minus 1/2 is 3/2. And you can understand this because it's a simple geometric shape, everybody. You know how to calculate the area for this guy and the difference in the area. Previously, we were looking at a case that we could not figure out, and we had to go with the Riemann sum. However, that Riemann sum can be also done by definite integral, which is the fundamental theorem of calculus, capital F of B minus F of A. I want to explain that here because I want you to see this can be easily calculated, and we will elaborate on this more later on. For now, what is the antiderivative of x? Is 1/2 x squared. You don't need a constant because you are going to evaluate it from 2, from -1 to 2. First, you plug in 2, you get 4. Then you plug in -1, you get 1. And the difference is 3. So this is 2 squared. This is -1 squared. 4 minus 1 is 3. 3/2. As you can see, they are identical. The difference is this one is proving that the fundamental theorem of calculus does it, and we don't have to go with the limit. Of course, we should know the limit, but this is much faster and easier. Definite integral makes it easier. So in fact, you can try the previous example later on using this concept. In any event, before we move on to the next one, I want you to work on this at home later on. Graph and use signed areas to show that the integral of -4 to 1, 6x dx is -45. Remember, in this case, f of x is 6x, and in this case, the interval is -4 to 1. So that would be a good practice. So we used geometry. It was a very simple case of a geometry. We're going to do the same thing here. We're going to use geometry to evaluate this. The integral of -3 to 3 square root of 9 minus x squared dx. We can't do this by the method of calculus 1 anyways. So this has to be done by geometry. Later on, we learn a method that can be done in calculus 2. Don't do that. You have to go with the geometry here. So to go with the geometry, you have to recognize the function is square root of 9 minus x squared in the interval of -3 to 3. That's the first thing we should recognize. So what is this? What is the graph of this function? So we need to know that the equation of a circle goes as follows. If it's centered at 0, 0, reminding you x squared plus y squared equals r squared. centered at 0, 0, the origin with the radius r. If it's centered at h and k, x minus h quantity squared plus y minus k quantity squared equals r squared. So circles, and of course area is pi r squared, circumference is 2 pi r. Information from before. Now let's call this y, and then if you square both sides here, class, if you square this one, bring them to the same side, you get this one. And this is a circle centered at 0, 0 with the radius 3. So what is this one? That's a semicircle of radius 3. So this is the circle centered at 0, 0 with the radius 3. But what you have is a semicircle, okay? It's going to go from negative 3 to 3. Therefore, we know the area is pi r squared, so pi times 3 squared for a circle, or this would be half of that. So the graph of G is a semicircle. It's important. You have to show, you have to prove, this is the proof that this is a semicircle. And let me just quickly remind you that when you have this formula, if you solve for y, if you solve for y, you get plus minus the square root of 9 minus x squared. Okay. The plus is the top, the negative is the bottom. If you solve for x, you get the right side. If you solve for x, so let me. If you solve for x, you get x equals plus minus square root of 9 minus y squared. So if you look at this circle, everybody, the top one has this formula. The bottom one has the one with the negative in front of it. The right side has x with the positive, and the left side has the x with the negative sign in front of it. It's a semicircle. So half of pi r squared means 9 pi over 2. That should be pretty straightforward. So geometry is helpful. Now, properties of definite integrals. Let f and g be continuous functions over the interval of a to b. The definite integral at a point, if you have the integral of a to a f of x dx, it becomes 0. Because delta x is 0. Delta x is b minus a over n, and it becomes a minus a. So it doesn't cover any area. So a point, the area under a point is 0, doesn't cover anything. Sum and difference rules. The integral of a to b f of x plus minus g of x dx, you can cut it into 2 pieces. So for example, if you want to add these two, you can. So this one and this one, they add up. F of x and g of x. A scalar rule or constant multiple. The integral of a to b c f of x dx, you can take the c out. So this is f of x. This is, let's say, 2 times f of x. Dominance. If f is larger than g from a to b, then the integral of f of x dx from a to b must be larger than or equal to integral of g of x dx from a to b. So f is above g from a to b, so it covers more area. That's really the bottom line. Bounding, max and minimum. If f of x is between m and m, lowercase m the minimum, uppercase m the max, from a to b, and then the integral of a to b f of x dx is between m times b minus a and capital M times b minus a. Think about it. Here's the function. The maximum occurs here if you draw a line and come up with the area of a rectangle. This rectangle, both this green one and this large one have the width of b minus a. Now, the height for the max is capital M, for the mean is lowercase m. That's it. And the area, the blue one would be the area, and of course, it includes the green one, area under the curve. So you can clearly see which one is larger. And so splitting additivity says if you want to go and evaluate the integral of f of x from a to c, you can do it from a to b and then from b to c. Notice a to c here. Okay, so in between you can have any number. That's the idea. So if we want to look at the graph, so we're going to go from A to B and integrate, from B to C and integrate. So from A to B and then B to C, from A to B and then B to C. As long as this number is in between, it works. In fact, it doesn't even have to be in between. Opposite rule. The integral of A to B f of x dx is minus the integral of B to A f of x dx because delta x becomes negative now. Constant rule. The integral of A to B c dx, we can say c times b minus a, because basically this becomes c times x. Non-negativity, if f of x is larger than or equal to 0 from x equals a to x equals b, then the integral of a to b f of x dx has to be larger than or equal to 0, non-negative. So, for example, if the integral of f of x dx from 1 to 3 is 6, from 3 to 7 is 9, from 1 to 3 for g of x. Now, the integral of g of x dx from 1 to 3 is negative 4. We're going to find the following, starting with part A. 3 times f of x dx from 1 to 3. So because this is 6, just multiply by 3. And you get 8. How about the integral of 1 to 3, 2f of x minus 4g of x? Let's take the 2 and 4 out, 2 and negative 4 out. So we get 2, the integral of 1 to 3 f of x dx, minus 4, the integral of 1 to 3 g of x dx. So this one, the answer is 6. So 2 times 6. This one, the answer is negative 4 minus 4 times negative 4. And this is positive 16. This is 12. They add up to 28. The integral of 1 to 7 f of x dx. Well, 1 to 7. We see 1 to 3 and then 3 to 7. So add them up. notice that the 3 here, they must be the same. So this is the same as the sum of these two, which is 6 and 9, 15. So that should be straightforward. And finally, the integral of 3 to 1 f of x dx. So if 1 to 3 is 6, 3 to 1 is the negative of that, which results in minus 6. Section 5.3, the fundamental theorem of calculus, short FTC. The fundamental theorem of calculus is appropriately named because it establishes a connection between the two branches of calculus, differential calculus and integral calculus. It gives the precise inverse relationship between the derivative and the integral. d dx of the integral of a to x f of t dt equals f of x. This simply means if you take the integral of f of t dt, evaluate from some number, a is any number, and the upper limit is the variable x, then you take the derivative of that, they will undo each other, they give us f of x back. So FTC has two parts. Suppose f is continuous on the interval of a to b. If g of x equals the integral of a to x f of t dt, then g prime of x is f of x. Now, this one, we could write it in this fashion. d dx of the integral of a to x f of t dt is f of x. That's the same. The second one, it's called the definite integral, and it's a number. The integral of a to b f of x dx is capital F of b minus f of a, where capital F prime is lowercase f, and that is what we have here, of course. The integral of 0 to 1 x to the power of 7 dx, the antiderivative, as you all know, it's 1 over 8. X to the power of 8, it's a power rule. We're not going to write a constant because it makes no difference. If you now want to evaluate it, the way it works, you plug in the upper limit first. So you get 1 to the power of 8, which is 1. Then minus the lower limit, which gives you 0, and you get 1 over 8. Now, here's the tip. Even if we use another antiderivative, capital F of x plus c. So if I put a plus c here, what happens? In the evaluation theorem, because it's a number, the result will be the same. Why is that? Because it becomes f of b, capital F of b plus c minus capital F of a plus c. Those cancel each other. Makes no difference. Now this one, please recognize x to the power of minus n or 1 over x are the same. So the answer is a natural log. We don't write a constant from 1 to 2. So it's ln2 minus ln1. ln1 is 0. ln2 is the exact answer. Again, you're a calculus student. The answers must be exact unless they ask you for an approximation. We're going to repeat the same question with different limits. So we get the same answer, natural log, but with different limits. Now, what is the difference between this question and a previous one? Previously, when we didn't write the absolute value, wouldn't make any difference. Now it does, because natural log, the domain is 0 to infinity, and natural log of 0 or negative numbers are undefined. So this is ln1 minus ln2. ln1 is 0. So it's precisely minus ln2. The integral of 0 to pi sine x dx, the derivative of sine is cosine. The integral is negative cosine x. And to evaluate this, it's easier to keep the negative out and plug in cosine of pi, which is -1, minus cosine of 0, which is +1. The bracket changes to -2. The negative in front of it makes it +2. The, the integral of 0 to power 2 1 plus cosine t dt. We've done this before. Now we are going to do the definite integral. Because the independent variable is t, 1 gives you t. And of course, cosine, the derivative is negative, but the integral is positive sine t. Now, the definite integral is a number. Plug in the upper limit power 2 minus plug in the lower limit 0. So this is power 2, this is sine of power 2, which is 1, and this goes to 0 because sine of 0 is 0. So the precise answer, power 2 plus 1. Again, exact answer. What about this one? The very first thing is to change square root of x, in each case to x to the power 1/2. And when we do that, remember this has exponent 1, these two become 5x to the power of 3/2. We do that to get it ready for the power rule. So 5 over 3/2 plus 1, x to the power of 3/2 plus 1. Second one, 3 over 1/2 plus 1, x to the power of 1/2 plus 1. And we're going to evaluate it from 1 to 4. Now, this is it. You're done with calculus. Everything is algebra. This was algebra also. So here's what we do. This is 5/2. Therefore, this is 2. 3/2. This is 2. You plug in number 4, and then you plug in number 1. Four to the power of 5/2 means square root of 4. 2 to the power of 5 means 32. This is 64. 4 to the power of 3/2 means square root of 4, which is 2 cubed 8 times 2 plus 16. This is 1, this is 1, so we get 4 here. They add up to 64 minus 4 is 60, and 16 is 76. I want to evaluate the integral of -2 to 2 f of x dx, where f of x is defined as true and x is between -2 and 0 inclusively, and 4 minus x squared when x is larger than 0, less than or equal to 2. When you want to evaluate this, even if the question was telling us that this is from -infinity to 0, would work this way. We cut it into two pieces. F of x, one piece is 2, so we have to write dx from -2 to 0, and the other one, 4 minus x squared, from 0 to 2. So even if this was -infinity to 0 and this was 0 to infinity, the process would be the same, because this says we want to go from -2 to 2, okay? So -2 to 2. From -2 to 0, we have to use this part, okay, if you happen to have it this way. All right, So this one is 2x from negative 2 to 0. This is 4x minus 1/3 x cubed from 0 to 2. So you plug in 0, you plug in negative 2, you get 2 times 0 minus 2 times minus 2, you get 4 times 2 minus 1/3 times 2, and then you plug in 0, that gives you 0. So you're evaluating, of course, very fast, everybody. This one is just 0, right? So what you're looking at is 4 plus 8 minus 2 cubed is 8/3. So 4 and 8 is 12. 12 times 3, 36/3 minus 8/3 is 28/3. So please understand, not a lot of calculus involved, mostly algebra. So we are evaluating. To recap, the purpose of this question to say, if you happen to have a piecewise defined function and you're evaluating a definite integral, pay attention to the limits to see which piece is used where. So from negative to 0, we use this piece. And from 0 to 2, we use the second. That's it. Find the derivative of the function where the function g of x is the integral of 0 to x squared of 1 plus t squared dt. According to fundamental theorem of calculus, d dx of the integral of a to x f of t dt is f of x. So simply put, this is the function, which is a continuous function. So if you want to take the derivative, just replace this. So that's the function, f of t, this one, f of t. So the function is f of t is the square root of, is this piece, square root of 1 plus t squared without the dt. By ftc, the derivative is the function itself, replace the t with the upper limit variable. So by ftc, g prime of x is the square root of 1 plus x squared. So replace the t with this function, this variable. Now, what about this one? The derivative d dx of the integral of 1 to x squared sine t dt. Well, notice f of t is sine t. Now, d dx of the integral of a to g of x, not x, but rather a function of x. When it's x, you just put the x there. But if it's a function of x, f of t dt, you have to put f of g of x. In other words, you replace the t with x. In this case, you have to replace it with x squared. However, by the chain rule, times the derivative of the inside, the derivative of g of x, which is g prime of x because you're differentiating. This g prime of x is by the chain rule. Therefore, if f of t is sine t, we are going to replace the t with whatever this is, the function x squared, so sine x squared, but times the derivative of x squared, which is 2x. This is by FTC. And of course, we put the 2x in front. Now I'm going to actually prove it to you in case and show it to you in case you actually go through the process of forgetting this one and integrating this one. If you want to integrate this, first, and then take the derivative. So the integration will give you negative cosine t. So we are going to integrate this. It gives you negative cosine t. I'm going to put the negative out and I plug in x squared. I get cosine of x squared. I plug in 1. Remember what we are doing. We found this. Now we're going to take the derivative and we have a negative sign. So what is the derivative of cosine x squared? Negative sine squared times 2x. What is the derivative of cosine 1? Cosine 1 is a number. Minus cosine 1 plus cosine 1 minus 8 plus 8. This is 0. And as you can see, this negative times negative is positive is identical to what we have here. So that proves actually that if you want to take the derivative of the integral of a to g of x f of t dt, you replace the t with the upper limit g of x and times g prime by the chain rule. But about this one, we are going to go with the same process that we just explained. We are going to look at this one and say f of t class is tan t. So replace the t with the upper limit. It becomes f of g of x. That means tan of x squared plus x. And then times its derivative. The derivative is 2x plus 1 times 2x plus 1. And of course, we put that in front. What if we have a limit of the integral of the limit of tan x to sine x t squared dt, and we want to take a derivative, and both of them, see, this one was a number. If you have any number, makes no difference, you're done. Change the 1 to any number, it's still the same thing. But if this is a function, first of all, the f of t is t squared, but the methodology is as follows, everybody. D dx of the integral of f of t dt, if the lower limit is g of x and the upper limit is h of x, first we put the upper limit times h prime, this is by the chain rule, minus, then we put the lower limit times g prime. This way, f of t is t squared. Replace the t with the upper limit, becomes sine squared of x, times the derivative of sine x, which is cosine x, minus, then t squared means tan squared x times the derivative of the tan, which is, so first we have sine squared x, then we multiply by its derivative cosine, minus, now second we have tan, so minus tan squared x, then we have to multiply by its derivative, which is secant squared x. What about d dx of the integral of sine x to 1 square root of 1 plus t squared dt? Anytime you are using the FTC that one of the limits is a number, make sure the number is at the bottom. Since this is at the top, this is the same thing. You put a negative sign and interchange 1 and sine x. So that's your function. You are interchanging. So this negative, because 1, which was the top limit, goes to the bottom, and sine, which was the bottom limit, goes to the top. That's why it creates a negative sign. So replace the t, this function, replace the t with sine x. So minus remains, square root of 1 plus sine square root of x. And now, by the chain rule, multiplied by the derivative of sine, which is cosine x. And put that in front, becomes minus cosine x square root of 1 plus sine square root of x. And that's the